Today we will learn about systems of equations. You will need this foldable to get started. A system of linear equations is two or more linear equations. For example, consider y equals negative 2x plus 3 and 4 equals 6x minus 2. Let's start with y equals negative 2x plus 3. We can plot this on the graph. The y-intercept is where you cross the y-axis. And so we're going to put our first point at 0, 3. Next, we will use the slope of negative 2 to find our next point. Negative 2 is the same thing as negative 2 over 1. And since our slope is rise over run, we can go down 2 because it's negative 2 and right 1. So our next point would be here. Keep going, moving down 2, right 1, and you'll get more points. Next, we will draw a line extending through these points, and now we are done graphing our equation. When we go to try to graph 4 equals 6x minus 2y, we can't really do that because it's not in slope-intercept form, or y equals mx plus b. So, in order to change it into y equals mx plus b form, we need to move our negative 2y over to the left side of the equal sign. So we're going to add 2y to both sides. Then we now have 2y plus 4 equals 6x. We want our constant on the right side, so let's move that over by subtracting 4 from both sides. And we now have 2y is equal to 6x minus 4. However, we do not want 2y, we want 1y. So we're going to take the whole equation and divide by 2. We then have y equals 3x minus 2 as our equation. Once again, we're going to plot our graph starting with the y-intercept. Since we have b is negative 2, our y-intercept is 0, negative 2. We can then move on to the next point using our slope. So our slope is 3, or 3 over 1. Once again, 3 is our rise, so we're going to go up 3. And then 1 is our run, so we're going to go over 1. We're going to mark our new point and repeat. Now that we've got a couple of points, we can draw our line. Notice how there is one point that can act as a solution to each of the two equations, so it exists on both lines. This point, 1, 1, is considered the solution to the system of linear equations. A solution is defined as any coordinate point that satisfies all of the equations in the system. Therefore, if we consider a point that's not on either graph, like 3, 3, or a point that's only on one graph, like 0, negative 2, then they will not be considered a solution. Now, let's add a couple other pieces of information to our notes. First, let's look at the solutions. All of the solutions in orange apply to the first equation. The points in blue are solutions to the second equation. And there is one point, 1, 1, which is a solution to both the equation. That is the solution to the system. We can check our answer by taking our equations, so y equals negative 2x plus 3 and 4 equals 6x minus 2y, and plugging in our x and y values. So our y value is 1. We have negative 2 times our x value is 1 plus 3. Let's do the math we can. So 1 equals negative 2 times 1 is negative 2 plus 3, which means 1 is equal to 1. And this is correct. Now, that means that 1, 1 is a solution to the first equation. Now, we need to check the second equation. So 4 equals 6 times our x value, which is 1, minus 2 times our y value, which is also 1. We can use our order of operations. 4 is equal to 6 times 1 is 6, minus 2 times 1 is 2. That means that 4 is equal to 6 minus 2, which is just 4. And since both sides are the same, we know that 1, 1 is a solution to the second equation. Since it satisfies both, it is the solution to the system of equations. Make sure you cut, fold, glue, and label your foldable.